It is the duty of a reporter to bring us all the news from places we can't be in person. From everywhere on Earth, Perseverance life from Mars, and even from the inside of a cell, we gain valuable knowledge due to the work of a good reporter. Getting to know what happens inside a cell, Promega developed in the early 90s the first commercially available luciferase detection reagent to be used for the luciferase reporter technology. This technology enables researchers to have a look into the core of a cell and switch the light on. During the last 30 years, Promega developed more and more smart scientific applications for the luciferase reporter technology. This video brings us back to the beginning of that path. It tells the story how luciferase reporters can use light emission to show if a gene, which may, in example, be related to a certain form of cancer, is switched on or off. Raise the curtain. Reporter gene assays are used to study signaling pathways, gene regulation, and the structure of regulatory elements. In its simplest form, a reporter gene assay consists of a regulatory element cloned into a vector upfront of a reporter gene. The reporter gene encodes a protein with an easily measurable activity. Promega is using the bioluminescent activity of luciferases for our reporter. Upstream regulatory elements affecting expression of a reporter gene can include potential promoters, known promoters, partial promoters, and enhancer elements. Now that you created constructs with your regulatory element and a reporter gene, the next step is transfecting cells. Done this, you are ready to investigate the gene regulation controlled by your regulatory element. The messenger RNA for luciferase is transcribed from active promoters. Experimental conditions can modulate the activity of a promoter. Weak promoters make less RNA. Enhancing the promoter's activity by, let's say, applying a new potential drug, you get a lot more of it. The cells translates messenger RNA into active luciferase. That means the amount of light you get is dependent on the level of promoter activation. And think about, the regulatory element you investigate is the one which controls the gene expression of your real gene of interest. But its gene product, aka protein, would have been hard to detect and quantify. Using luciferase instead as a reporter serving you a light signal makes it easy. But you will need a safety net to correct for variables in your reporter assay. Cell number and transfection efficiency can also influence the amount of luciferase. That's why Promega introduced the dual luciferase reporter assay. For dual luciferase assays, transfect with a control plasmid expressing a second luciferase. This one under the control of a given promoter, which cannot be modulated by your experimental conditions. The ratio of experimental luciferase activity to control luciferase activity corrects for variables in your reporter assay. Promega supplies 3 different luciferases. Firefly is great for routine reporter gene assays. Renilla luciferase is used as a control. Our latest development is a nanolook luciferase, a smaller, brighter luciferase best suited for research in challenging biological systems. Nanolook has also a big potential for smart applications in molecular biology beyond reporter gene assays. But this is a different story to be told another day.